Hello, good evening students. Now today we are going to understand the elimination reaction. Elimination reaction of elimination reaction of haloalkanes. Haloalkanes. Dear student, so there are elimination reactions. It follow that is a certain types are there for the elimination reaction. When you are talking about the first type, when this one is the E-1 elimination, this is the E-1 elimination, elimination. When you are talking about that is again is there, that is E-2 elimination, E-2 elimination, and last one is there, that is saytjeff rule, saytjeff rule. So there are the three ways we can do the elimination reaction of the haloalkanes and haloanes. So what is the process for the E-1 elimination reaction, student? It is just like E-1 elimination means just like that it is S1 type of, So this comes under that is it gives it follows what, student? It follows that is carbocation formation. It follows, the first point is it follows that is carbocation formation. This is the first things that we have to keep in mind. And second point, that is in the second point in this case, that is it takes place, where it will takes place, student, takes place in, that is 3-degree alkyl halide. Now student, how can you be able to understand? Suppose we are having that is 3-degree alkyl halide is there. Okay, here is Cl and this one, this direction CH3 and this direction CH3, this is also CH3. So what is happening in this case, student? This is reacting with the alcoholic KOH. It is reacting with the alcoholic KOH. So alcoholic KOH is a strong base, student. So what it will do, student, it will directly eliminate, and what it will form, it will not give the substituted product, student. It will give here is CH3 and here is double bond, that is this will go CH2. This is alkene. Now student, we have to understand how the reaction taking place. So let us try to understand the mechanism of E1, mechanism of E1 reaction. So how can you write the mechanism of E1 reaction, student? So it involved in the two steps. Step number 1, if you talk about step number 1, so that is formation of carbocation. That is in the first step, that is formation of carbocation takes place. So that is here is what is, student, that is Cl is there and this CH3 as usual, that is 3-degree alkyl halide. So what is there is the difference in electronegativity. So will be there taking place the homolytic fission, student. So in the case of homolytic fission, that will be the reversible process. So what it will give, student, it will give that is CH3, okay, and here will be also CH3 and downside CH3, and this is the positive charge. Step number 2, okay, step number 2, that is you can write that is elimination of what, student? Elimination of H plus. How elimination of H plus will be taking place, student? Let us see. So in this reaction, the same is I am writing this carbocation. So positive charge is there and this is CH3, this side also CH3 and this side, that is CH2 and H is there. So what will happen there, OH base, what it will do is, student, this OH base will attack on this hydrogen and this bond will be shifted here. So what will be the final product will be there, student? Here is CH3, no problem. This side also CH3 as usual place, and here will be the double bond CH2 plus water will be formed. So in this total process, student, if you check out the total process, what you will be finding, student, in this total process, you will find that there is a loss of hydrogen as well as halogen. Okay, so here is the loss of, you will find that is, here is the loss of halogen will be there, and this will be the loss of hydrogen from here. So this elimination reaction is also known as dehydro. This is known as dehydrohalogenation reaction. Okay, that you have to keep in mind. That is, two things are getting eliminated. That is why this reaction is also known as dehydrohalogenation reaction. Now student, what we are going to do, we are going to understand the E2 elimination reaction. So E2 elimination reaction follows just like the SN2 reaction student. So in E2 elimination reaction, it generally takes place in the 1 degree alkyl halide student, and that reaction is also known as beta elimination reaction. This reaction is also known as a student, that is beta elimination reaction. So let us try to understand student, how can you be able to understand in this reaction when you are talking about, that is takes place in where student, takes place in 1 degree alkyl halide, 1 degree alkyl halide. That is the very first point student. And when you are talking about the second point, that is transition state form, transition state form. Okay, this is the second point. Okay, so student, how the reaction will be proceed here in this case, you check it out student. So here is, suppose we are having that is CH3 CH2, and here is I am putting Cl, and this hydrogen I am breaking out, and here I am putting that is hydrogen, and here is 2. So you can match it out, the valency of this carbon 1 2 3 4, and this one also. So what is happening student, in this case the attack will be from the back side. So backside attack is from OH minus ion will be attacking from the back side. So if OH minus ion is attacking on this hydrogen, so this bond is breaking out, and this bond will be chlorine will be coming out. So what the transition state will form student, let us check it out, this transition state formation. So here is what is happening student, CH2 is there, and this side this side what is happening, this one is the OH, OH is getting forming the bond with which one student, with the with the hydrogen. Either you can write in this one in the bottom also, there is no problem. Here hydrogen is there, so here is OH is forming the bond student, OH. So in this case, here will be, this bond will be shifting out. So if this bond is shifting here, so here will be double bond, and then here is CH2 is there, and this bond will be the broken out. So this will be going like. So next step what will happen student, it will be minus Cl and minus H2O, minus Cl minus H2O, and finally it will be shifting here. So what it will form student, CH2 double bond CH2. This is what is known as student, this is what is known as ethene, right? So this reaction is what is SN1 reaction. This step is known as TS, transition state. Okay, so this is the mechanism of the SN2 reaction, E2 reaction, that is just like the SN2 mechanism. Now next one is there student, that is known as what, saytjeff rule. So let us try to understand the saytjeff rule, and that is the quite important. The out of all the elimination reaction, saytjeff rule is the most important rule for the competitive exam also. Okay, so saytjeff rule, what it is saying student, what is the saytjeff rule is saying? Saytjeff rule is saying, if there is more than 2 beta hydrogen present in where student, alkyl halide, in alkyl halide. So that is alkyl halide. Then the preferred product, what would be the preferred product? Then the preferred product will be what student, product will be, that is will be having, preferred product will be having more number of alkyl group, more number of what student, more number of alkyl group. Okay, more number of alkyl group. This is our will be answer in alkyl group. So student, how you will be able to understand the mechanism of this reaction? Let us try to understand this. Suppose we are having CH3, here is CH, okay, and here is, suppose that is the CH, and I am putting hydrogen here, and then again I am putting, here is CH, and this side there is Br is there student. So CH2, and there is what this is the Br, and suppose this is the also CH2, and here I am putting hydrogen. So case number 1 I am doing student, case number 1. So case number, if you are treating this with OH, So probability is there if it is attacking at this hydrogen. So this bond will be shifting out and this will be coming out. So what the product will form is, student, CH3. Okay, there is nothing happened with this carbon, so it will be there CH2, and that is, here is the what is writing, student. This is the one bond is going, bromine is going, and this bond is forming. So that is CH double bond CH2. Okay, so it is having only one alkyl group, student. This is only one. So this is not symmetrical alkene. So this is known as what? But1-ene. This is also but1-ene, and this is also known as Hoffmann product. Hoffmann product. If the Hoffmann product, and this is only 19%, student. 19%. Now you see the case number 2. According case number 2 for the saytjeff rule. Case 2 for the saytjeff rule. So dear student, how you will be able to do the same compound I am writing, CH3, and that will be CH. Okay, suppose this hydrogen is here, and that is, here is CH, and that is Br is as it is, and here is CH3. So if you are taking place by OH ion is attacking with this, so this bond will be shifting here, and this all the bromine will be out. So what the compound is getting formed, student, you see CH3, now it is CH. Okay, and this is bond is shifting here, so this will be double bond, and here is CH, and that is CH3. So how many alkyl group are there? Here is only one alkyl group, student. Here is two alkyl group. So product will have more number of alkyl group. So two alkyl group. So here is what is there, student. This is the two alkyl group. Two alkyl group. So two alkyl group present means this is the saytjeff product. Saytjeff product. Now if this is the saytjeff product, student, so it form how much, student? 81%. So this is the major product. So either you say that is saytjeff product, or the one more name is there, student. We use one more name. The other name is known as also Jatsav product. Okay, ZETSAV, Jatsav product. So it is having the two names, student. Jatsav product or the saytjeff product, both are the same. So this is all about the elimination reaction of the haloalkane and haloarenes. Okay, thank you so much for watching, friends.